Hello everybody, and welcome to the top of page 33 in the workbook. This is going to be a very brief video that just introduces a definition that gives us, talks about the second derivative in one specific situation that's going to come up frequently over the course of the semester. So let's read this together. So we'll let s equal f of t be the position of a moving object at time t. So maybe we're measuring time in seconds and s in meters. I'm just kind of making up the units there. We'd like to think about what the first and the second derivative represent in this situation. Okay, so starting with f prime of t, okay, the rate of change of position, what are we really talking about when we mention that? Okay, well, the units of f prime of t would have to be meters per second if we assume that time is in seconds and s is in meters. So what kind of a quantity is measured in meters per second? We're really talking about velocity. Okay, that's the rate of change of position. And we've actually already seen this application a few times before. What's new in this definition, though, is the next sentence. What about f double prime of t? What is it that we'd be measuring there? Okay, well, let's think through this. Okay, so the second derivative is the rate at which the derivative is changing. And we just mentioned that the derivative is velocity. So is there a word to describe the rate at which the velocity of an object changes? Okay, imagine that you're sitting in your car on the highway and you press on the gas pedal. Okay, well, your velocity is going to increase if you do that. And how would you describe what's happening to you in the car? Well, one way is to say that you're accelerating. And so the rate of change of velocity is the acceleration of an object. Okay? And we'll make one note, okay, just about general units before we close this video here. So if we now assume that t has units of seconds and s of t has units of meters, okay, that's kind of the assumption that we made already above, then velocity is going to have units of meters per second. Okay, and what would the units of acceleration be? Okay, if you've ever taken a physics course, you may have already run across these units. So we're talking about the rate of change of velocity with respect to time. So we would be talking about meters per second if we're talking about the rate at which velocity is changing. And just because that's kind of hard to say, meters per second, usually what we do is we say meters per second squared. Okay, and that's just a kind of a shorthand way of saying meters per second.